Hello, dear children. So last little charla we talked about how general arguments, disagreements depend on earlier disagreements, okay? And we call those the earliest, the first disagreements, we call those first principles. A principle is that from which you start, okay? Principle. And so we had that experience in Euclid, for example, and I want to talk about that right now. So anyway, first principles. There's three different kinds of first principles, okay? And you had the experience of one kind in Euclid. So, and that was the self-evident kind, okay? So one kind of first is something that is self-evident. Hey, the whole is greater than part. All deal. Do you remember how when we drew it on the board, because one person didn't see it, so all we had to do was draw a circle and then cut it and part of it, say the whole is greater than part. Oh, all deal. Okay, so the person didn't see it right away, but when he did see it, it wasn't proved to him. You just say, look, and you kind of clear up any confusion that he might have, but he just saw it first with his intellect. Those are called self-evident first principles. You don't prove them, they're just self-evident, okay? The second kind, we'll talk about those in a second. The second kind are self-explanatory first principles. Modern science uses self-explanatory first principles, whereas in self-evident first principles, the person sees that the principle is true, okay? In self-explanatory first principles, the person sees that the thing very likely could be. It seems it's a good guess, okay? Self-evident, you see that it's true, and the consequences follow necessarily from the truth of the principle, okay? Like in Euclid. The propositions follow necessarily from your definitions and your common notions. We've done that. So, okay, principles, consequences, the truth of the propositions follow necessarily. So say in where you prove that the exterior angle is greater than the interior and opposite angles either, that depends on your knowledge of parallel lines and a transversal falling upon them, making alternate angles equal. Okay, so one knowledge depends on another. Well, that depends on this, and that depends on that, and everything finally depends on the first principles. Self-evident first principles. You see that they're true, and you see that if there's a good argument, logical argument, the consequences are necessarily true. What follows is necessarily true. Whereas in self-explanatory first principles, that is to say, you understand what the words mean when you look at it. Yeah, I understand that. Like say in Newton, as we talked about in the science class before, that if you set a body in motion, it will remain in motion until something hinders it, okay? That's self-explanatory. Everyone can see what the words mean and everything like that. Whether it's self-evident, I don't think that that's self-evident. I think it's a cool first principle. I like Newton and everything like that, but I don't see it's true in motion because it seems like it has philosophical problems in the physical world, like if you can take into account the material world as well. I know people would disagree with me on that, but that's okay. Okay, so the second kind of first principle is self-explanatory, whereas you take it as a good guess, the principle, and then you judge that principle by the truth of the consequences. In Newton, say, we got rockets to the moon using Newton, just as it was planned out. You say, wow, that must be true. Okay, so you judge the truth of Newton's first principles by the consequences, and you experiment. You have real life experiments, and you see, wow, that's true. Look, it predicted it, and we predicted that the rocket would land on the moon, and it did using Newton's principles. So the principle must be true, and we'll talk about that later with, say, comparing Einstein and Newton. Okay, so the principle in a self-explanatory first principle is a good guess, and you judge the truth of the matter, you judge the goodness of that first principle by the kinds of consequences you get from it. You get expected consequences, or bad unexpected consequences. Or what's even better is you get good unexpected consequences. Wow, I didn't even predict that, but it happened. That makes it even more believable. We'll talk about that one day. Okay? You might say, let me give you a hard one, okay? I'll read this out. This is a first principle of Einstein in the general theory of relativity. I just want to say this, right? Okay, his first principle, you ready for this? You might not even understand this. A ray of light in gravity-free empty space travels at the same velocity relative to all inertial observers. A ray of light in a gravity-free space, resistance, empty space environment. That ray of light will travel at the same velocity no matter how fast you're going. So if you're just sitting here and it goes doo, and then if you're going doo and it goes doo, it will go doo much more fast relative to this guy. But relative to you and relative to him, it's traveling at the same speed. You say, wait a second, I don't even understand what that means. You would if we talked about it more. So it's self-explanatory. You say, there's no way I can know if that's true or not. Okay, well, let's do experiments. And you know what? They did experiments with Einstein, and wow. They came up with the conclusions of doing the experiments. They say, well, if that's so, then this would happen. In looking at the way this planet's going to go down over the horizon, and we measure the ray of light and all that. I don't even know what that is. I didn't do the experiment. And they say, wow, that's exactly what happened. The first principle must be true. Okay? So self-explanatory principles in modern science. Great. Then the third one is really cool, and they're called borrowed principles, prestados. Okay? And so you have that, say, in physics and in theology. Physics is an easy one. So physics will take the Pythagorean theorem. Physics is not geometry. Physics uses one of the results of geometry, the Pythagorean theorem. You're going to do that, by the way, in Proposition 147. The square on the hypotenuse in a right angle triangle is equal to the squares on the sides. Okay? You're going to prove that. But physics, you can do physics without proving that. Say, okay, well, that's true, right? You guys say that it's true? Yeah. Okay, let's use that, and then you do physics. By the way, you can also do Euclid and do physics. So, but even insofar as you're doing physics, you're using a principle that's not proper to physics. You're using a principle that's proper to geometry. Okay, so you borrow that in order to do physics, which is cool. And then a second kind of borrowed principle would be in theology. Okay, and we're used to that. We've done catechism. Say that God is three persons in one nature. Say that Jesus Christ has two natures in one person. That seems, I don't see that with my intellect. And let's say that the indwelling of the Holy Spirit can happen, and it gives you 7 gifts: science, intelligence, or understanding, sabiduría, wisdom, the consejo, courage, fear of God, and piety. You say, wait a second, is that no, that's true. Okay, I'll accept that as true. You borrow those from whom? From God. God gives you those principles. And then from those principles, you can do the science. We can talk about why it's a science. The science of theology. Okay? So to repeat, 3 kinds of first principles. Self-evident first principles that you can have in the life of the mind in general, say with Euclid and philosophy and theology and history and literature. Self-explanatory first principles that you get with modern science. We talked about Newton and Einstein. And then borrowed first principles that you can get with, say, physics and theology. Okay, thank you. Bye-bye.